Today, we are going to talk about text mining and sentiment analysis using Power BI and Azure. Just a show of hands, is everyone familiar with Power BI? Right? Most people are. And Azure? Perfect. Okay. So the subtext is text mining and sentiment analysis made easy. So even if you don't have a lot of familiarity with Power BI and Azure, hopefully this won't be a steep learning curve. You have probably seen this slide a million times by now. Please silence your phones. The session is being recorded. PASS is more than just the summit. So there are all these awesome things that PASS does. If you don't already participate in these things, please do. All right, so I'm Sanil. Hello. I am a senior data engineer with Worldwide Technology in St. Louis, Missouri. Is there anyone in the room from Missouri? Hello. Right. So our company likes to brand itself as Silicon Valley in St. Louis. So if you ever visit Missouri, feel free to swing by. We have shiny Silicon Valley-like offices in St. Louis. I am a data engineer. I have worked as an architect, as a DBA. I am currently doing data engineering and analytics with Worldwide Technology. I have worked with SQL Server, Oracle, Big Data, and Cloud. And I am sure I'll get a lot of boos when I say this, but I have to be honest. For the last 2 years, I have heavily been working with Oracle. I have kind of sort of lost a little bit of touch with SQL Server, but please be kind to me. So what are we going to talk about today? 7 things. We are first going to quickly talk about the distinction between qualitative and quantitative analysis. We are going to look at the text analytics APIs in Azure. Then we are going to jump into Power BI with a real-life example of how to use Azure and Power BI with the text analytics APIs to do sentiment analysis on a real-life use case. That involves extracting key phrases from text and generating sentiment scores. Once you have done all of that, it's not really fun to give your business users or your analysts just a spreadsheet that has key phrases extracted or sentiment scores extracted. It's not really useful for them. So we are going to look at some visualizations and dashboards in Power BI. We are also going to look at an R script that does something that Power BI does not offer built-in. And then we are finally going to talk about gaining some insights from all of these analyses. All right, so qualitative versus quantitative. You have 2 types of data. You have text, you have numbers. The way you analyze these 2 different types of data is different, right? So with text data, you can read that text data, identify trends, identify words that repeat quite frequently, and build maybe a word cloud on top of that, or do a count and display something like the word great appears 1,000 times in this particular text. So maybe people think this is great, things like that. But it helps you understand perceptions. It helps you with understanding or making some sense out of comments in, say, reviews or free text responses in surveys. One of the things that we use this for in my company is we have a quarterly employee feedback that HR sends. And sometimes they have open-ended questions. So all of this started with HR reaching out to my team, analytics team, that, hey, we have this survey feedback and we have 800 responses, and we don't really have the time or the energy to read through those responses one at a time. So analytics, can you help us out with something like that? So that's where all of this evolved. And you'll see an example of how this is now used on a quarterly basis for team health. But there is qualitative data, and that's what we are going to look at. And there is only a certain number or a certain number of things that you can do to analyze qualitative data. To be able to apply statistical techniques on top of that qualitative data and to make it open to a lot of different types of analysis, you have to convert that into numbers. So that's where your quantitative analysis comes in. And that's where the sentiment score comes in. So you take your text, you generate a sentiment score out of it. Now your data is numeric. And on top of numbers, you can apply all kinds of statistical analysis. You can do aggregates, sums, slice, dice. You can build histograms, box plots, all of that fun stuff. So we are going to combine these techniques in the example that we look at. There is a lot of value to be gained from qualitative analysis, and there is also a lot of value to be gained from quantitative analysis. But those two analyses should not be looked at in isolation. So you combine those two techniques by first looking at the trends or the most frequently occurring topics in your text data, and then you convert your text into numeric scores and apply quantitative techniques on top of it. So the use case that we have here is team health survey. Just wanted to show a quick show of hands. Does everyone work in Agile? Okay, a good number of people do work in Agile. So in my company, we are Agile across the board. Even our operational teams work in an Agile fashion. Doesn't always work the best, but that's my personal opinion. But everyone works Agile. And we have our retros, and once every quarter, all of these teams are supposed to do a team health. And in that team health session, there is usually a half an hour conversation that is a retro style conversation. And at the end of that conversation, an open-ended question is asked to the whole team. Given this recent conversation, how do you feel about your team's health? And people can rant about it, or sometimes people write just one sentence or one line, I feel great, or they write, our team sucks, something like that. So you can get like 400 words of responses, or maybe just 4 words of responses. So that's the use case that we are looking at. This data obviously has been de-identified, but outside of the de-identification process, this is real team health data from the IT department of my company over the last 4 quarters. So we have 9 teams. We just asked one open-ended question at the end of a 30-minute conversation with the team. There are 3 managers and 4 quarters worth of data. I quickly wanted to show the Excel spreadsheet. And for some of this presentation, I'm going to sit down now. I'm not very good at standing up and typing. All right, so this is the team health spreadsheet raw data. You have a column for period that has year and quarter number. You have the name of the manager, the name of the team, and the actual response. So if you look at line number 2, for 2019 Q1, manager 1, team 1, the response is, we are a fun team, and it goes on and on. So we have 300 odd rows here. Yep, 300 rows here, to be exact. And we are going to look at how to analyze this data using Power BI and Azure. Generate key phrases, generate sentiment scores. So before we jump into generating our key phrases and sentiment scores, let's take a quick look at Azure. How many folks here have used Azure Cognitive services? A couple, okay. All right. So Azure Cognitive Services is a collection of their machine learning and AI algorithms in the cloud. You have vision, speech, search, decision. Sir, you mentioned you used Azure Cognitive Services. Which of these have you used?
We use it for text analysis.
Okay.
Like, substitution.
Okay. I was hoping you would say vision because I'm looking forward to learning that piece.
No, we have use cases for that.
All right. Maybe next year you can present about vision. All right. So we are going to focus on the text analytics part of it. And inside of text analytics, you have various features. It can detect key phrases, it can detect sentiment scores, it can detect language, it can also detect topics of interest, all kinds of fun stuff. So it offers natural language processing over raw phases. We talked about the fact that you can extract key phrases from the API, sentiment scores from the API. It can detect language and more stuff. So you can take it for a spin. You don't have to buy anything. You can just take it for a spin using this URL. So I have just entered a text over here that my theme is great and fun to work with, and I hit analyze before starting this session, and it said that the sentiment here is 92% positive. Makes sense because I'm saying that my theme is great and it's fun to work with. And the key phrase here that it extracted was theme. Any questions so far? Yes.
Phrase, team. Is that saying that sentiment scores are derived at based heavily on that word?
No, so there is a difference between the key phrases and the sentiment score itself. The key phrase can be one word or multiple words. If your sentence is more complex, then it will probably extract a combination of words as key phrases of interest. Here, it's a pretty simple sentence, and the key phrases being extracted need not necessarily be the parameters on which your sentiment score is generated. So here, great and fun are the words based on which the sentiment score is generated, but the topic of interest is the theme because you're talking about your theme. Yes?
I'm sorry. Going forward, could you repeat the question?
Oh, yes. Thank you. The question was
Context of phrases.
about.
The context of phrases as opposed to sentiment score.
Yep. Yeah. So the question was about the key phrases and the sentiment, and please refer back to my answer.
Thank you.
All right. So to be able to use the API that we just took for a spin, we are going to spin up Azure Cognitive Services in Azure Portal. Is everyone here familiar with the Azure Portal? Everyone has logged into the Azure Portal? No? Only a few people? All right. So portal.azure.com, and you can create a free account. The Azure Cognitive Services are also free to use for the most part, so long as you are not using it for production workloads. So you can always go into Azure Portal, spin up Azure Cognitive Services, and take it for a spin. All right. So to be able to spin up Azure Cognitive Services, you simply create a resource and go into AI plus machine learning, text analytics, fill in all of these details, and hit create, and it spins up Azure Cognitive Services for you. It's as simple as that. Once you have the Azure Cognitive Services ready, I have already created one, Sanil Text Analytics. There are two things that you want to capture. One is the key, and the second one is the URL endpoint. These are the two things you are going to use in your Power BI functions to be able to pass your text to the cloud and get your responses back. Once the session is over, I'm going to regenerate all of these keys because that's the authentication to the API. So if you happen to expose these keys, just remember to reset your keys. There is no username password to be able to invoke the API. Yes?
Quick question. So is this only available through Power BI, or can you do this with ClickView, Tableau, and other?
Good question. So the question is this available only through Power BI, or can you do this through other things like QuickView or Tableau? The answer is yes. You can do this through pretty much any piece of code, any software that has the ability to invoke an API. You can even write your own code. What I have shown here is a demo version using Power BI. As I said, the place that I work at is not necessarily a Microsoft shop. So we use Tableau, we use Oracle, and we use Oracle Data Integrator for our ETL. And we invoke these APIs via our Oracle Data Integrator ETL tool and put this data directly into tables and then present it via Tableau. But this is how it started, because getting it off the ground was really easy using Power BI. All right, so you now have spun up your Cognitive Services API, you have your URL endpoint, and you have your API authentication key. So let's get started with the demos. All right. So there is obviously a sacrifice to the demo god. So I have one set everything ready, and then we are going to try to pray to the demo gods and hope that the demo that I'm doing on the fly works. So here goes nothing. The first thing that I am doing is the spreadsheet that I showed you earlier. I am simply importing that spreadsheet into Power BI, and that piece is not really interesting to show. So I've skipped over that piece. I did that piece ahead of time. Your spreadsheet has 4 columns, and once imported into Power BI, you can see there are 4 columns. The next piece is interesting, where you have to write custom functions to be able to invoke the APIs. So we are going to go into new source and write a blank query. These functions are in mQuery language, and they are pretty straightforward. You can look up these functions online on any blog post. I do not take any credit for writing any of these fancy functions. People much smarter than me have written these functions. I'm just using them. And at the end of my slide deck, on the resources page, you will see links to where you can find the code for these functions as well. So the key phrase function, you simply copy this function over, and you are going to rename your query now to key phrases. Go into the advanced editor and paste the code over here. No syntax errors, awesome, done. So creating a function to be able to invoke the key phrases part of the API is literally as simple as that in Power BI. There's a good reason why in the topic of my session, I said sentiment analysis made easy, right? Boy, this is a tough crowd. All right, so the next thing that we are going to do is generate sentiment scores. And that part is also as simple as the previous one. So we'll call this sentiment score and go into the advanced editor. The second mQuery function is for sentiment scores. So we are simply going to copy the text into this advanced editor window, hit done, and now the functions are ready for us to use. The next step in being able to generate the key phrases and sentiment scores is the ability to call these functions. Yes, sir, you have a question?
Same API key in both?
Yes, yes. The API key is at the grain of your service. So the same API key will be used for all of the functions used within the API.
Can, I mean, if you store it in a secure place, can Power BI refer to the API key? Because if you have to change it, you have to change it in both places.
Yes, so the question is there another place where you can store the API key? Because if you change it, you have to change it in both places. That's a good question. I have not explored that option yet, and I will do some research and get back to you. But what we do in productionized scenarios is in our ETL tool, we have an encrypted variable where we store this API key and then use that encrypted variable in our API calls. So you only have to make the change to that one encrypted variable. It's pretty much like how you store your credentials in an ETL tool. That's a good question and gives me some homework. Okay, so we have now the functions ready, and the next step is to invoke those functions. The output of these functions we are going to append to our data table. So for every line, we now want 2 new columns added. One would be the key phrases. So it's going to read this text and extract the key phrases, put that into a new column. And the second is going to be the sentiment scores. So let's add 2 new columns now. So you go into the Add Column ribbon and go to Invoke Custom Functions. The name of the new column, first one is key phrases. The function that you want to execute, you just select it from the drop-down box. And the next field asks you what column do you want to provide as an input to this call. So all of my text is in the response column. So I simply select the response column, hit OK. And your key phrase field is generated. It's just showing you a preview right now. When we run the whole thing, it's going to ping all of the 300 rows against the API. The second column that we're going to add now is your sentiment scores. So the query is going to be sentiment score, and again, the input is going to be response. So let's hit OK, and it has added a new column here with sentiment scores. I'm not a big fan of all of these decimal places, so I am going to change this to be able to only, oops, I always forget where do I go to round these things. There it is. We mostly use Tableau in our company, so navigating through Power BI can be a little bit of a challenge for me. Apologize for that. 2 decimal places. All right. So all of this is the preparation work, and you saw that the preparation work was pretty straightforward, right? So this is why I say sentiment analysis made easy using Power BI and Azure. Typically, a developer level skill is not needed for this task. Mostly this kind of work can now be done by analysts. So you don't need somebody with a PhD, you don't need a data scientist to do text mining, fancy sentiment analysis. Azure and the power of its black box does all of the work for you, and Power BI basically makes it really easy to invoke. A developer's role comes in when you want to productionize something like this, use an ETL tool to build the workflow. All right, so all of this has been done, so let's now close and apply. So it's going to spin for a few minutes, And while it's doing its work, we can quickly take a look into the metrics for our services, and that's going to show a spike. So total calls. And this is from when I tested my demo a few minutes ago. Pretty soon we should see another spike. And we can come back to that spike. But this is proof that I'm not doing pre-packaged stuff. It's actually running stuff live. Yes, sir, you have a question?
Yeah, so the stop word removal from the corpus, part of speech detection, is everything done in cognitive service?
Yes. So the question was, is the part of speech detection, all of the stop words, all of that stuff, is that done in Azure Cognitive Services? The answer is yes. If you are familiar with doing this in R or Python, you might see you have to write about 20 or 30 lines of code, do all of the steps that you just mentioned manually. And I have an R script as well where I do some of these things manually. But I love the fact that with Power BI and Azure, you can simply invoke the API and it does all of these things for you. Something interesting to note is with Microsoft's power of the cloud, these APIs are evolving and learning as well. So they get smarter, they get more reliable as time passes. So one more question?
Yeah, so the label that is applied to the text is basically how good a word is, right? So that's your sentiment score. If there's a positive feedback, that's what you want to find out. Is there, what other capabilities are there? Let's say you want to label your data different, you want to look at, I don't know, like a particular code in a particular industry or something like that, not just trying to answer a question if something is good or bad. What
Okay.
opportunities are there?
Okay, so the question is, right now, the API has the ability to label your data in terms of sentiment scores, but are there any other labels that you can apply to it? So one label is the key phrase, because that key phrase helps you identify the topic that is being talked about in that piece of code. Language detection is another feature. And I'm sure Microsoft, the smart guys at Microsoft, are thinking of more things to do. But right now, I'm aware of the fact that we have key phrases, we have sentiment scores, and we have language detection available.
So anything else has to be basically handwritten then?
Yes.
Yeah, okay.
Yes.
Yeah.
Yes, anything else, you basically have to write your own script, Python, R, and there is one thing that I'm going to show that's not built in, and I have used an R script for that. Are there any people in the room that attended Kevin Klein's session yesterday about communication with your peers and colleagues? No one? Okay. So I won't break the suspense yet. I'll talk about it when we get to that slide. But there are some interesting things that you can do using R and Python that are not directly available in Power BI and Azure so far. All right, so you can see the second spike here on your metrics, and it's telling me that there were 596 calls made to the API, which sounds pretty close. We passed in 300 rows, and we invoked the API twice, once for key phrases, once for sentiment scores. Yes?
Since you have worked in the production, so is the pricing is based on the number of API calls or based on the spinning operation?
Okay. Good question. So the question is, in an operationalized or a productionized copy of this, a productionized implementation of this, is the pricing based on the number of API calls, or is it based on the server? Yep. So there is no server. You can think of this as a service. So just spinning the service up is not going to cost you anything. The pricing is based on number of calls, and generally the pricing tiers that I have seen, for my use case, the free tier works perfectly fine. It limits you to 5,000 calls per month, and that has been enough for me so far. If you have a heavier workload, you can go to the standard tier or more premium tiers, and at that, they charge you per 1,000 calls, and it's ridiculously cheap, like 20 cents per 1,000 calls or something like that. So it's like literally loose change kind of pricing.
Yeah, this information is
Cool.
Thank you.
Okay, so we have got all of our data back. We now have key phrases and sentiment scores populated. Yes, there's a question?
Yeah, I was just curious how the privacy of the text that is sent out to the service, how is it stored?
So,
I mean, I know in training is one thing, but is the storing it?
Yep. So you can think of the privacy of this to be pretty much at par with Alexa or Cortana or Google Home. Once you have sent your data over to Microsoft or AWS or Google Cloud, they are free to do what they like with it. So don't send mission critical, trade secret, company secret kind of information over to the cloud. But for the most part, you can trust Microsoft, Google, or Amazon to not misuse this data. There is a whole, you can reach out to your Microsoft rep and hash out all of those details. But I have not run into issues so far, but yes, in transit, it's encrypted, but once it lands in, Microsoft claims that they use all of this data in a de-identified fashion to continuously train their algorithm and make it better. Outside of that, they claim that it's not used for any other purposes. So we can go with what Microsoft tells us. Okay, so now we have our key phrases and sentiment scores. If you were to extract this out into a spreadsheet and just hand it over to your analysts or just take a look at it on your own, it's not terribly useful. So that's where the power of your visualizations, the power of your dashboards come into play. So now I am going to not create a lot of dashboards from scratch, but I'm going to show you some of the dashboards that I have already created and talk through how those dashboards are created. So the very first dashboard is a summary page. In the summary page, you want to give your users some kind of context about this analysis. So you tell them that this is a team health dashboard, there are 9 teams, there are a total of 3 managers, and you are working through 300 responses. The next phase is the word cloud. So the word cloud is the qualitative analysis that we talked about. So this is where you can identify the trends, you can identify the topics that are popular. And I have added a few filters over here. On the left-hand side, you can see there is a filter on period, theme, and manager. So you can drill down to the grain of which topic was most popular for team number 1 in quarter 1. Which topic was popular across all of the teams for manager number 1. Those kind of slicing and dicing is possible. You can also do something like has the popularity of a topic changed between or across quarters. So in this particular scenario, I just wanted to show an example here where in the word cloud, one of the topics that shows up is Project X. Now, our company went through a big disruptive, transformative project. Let's call it Project X. And in the last 2 quarters of 2018, all of the teams were working overtime to deliver on this project. So every team was talking about Project X. But if you look at the same word cloud for 2019 Q2, no one's talking about Project X. So these are the kind of insights that you can draw based on a word cloud, that what are the trending topics, what are the popular topics, what are people talking about. But you don't necessarily know, are they talking about these things in a positive context or a negative context. So that's when you depend on the quantitative analysis. You look at your scores and you can slice and dice and do all fun mathematical and statistical things with your score. But how did we create this word cloud? Is anyone here familiar with Tableau? All right. So how much fun is it to create a word cloud in Tableau? It does take a few clicks, right? You have to do a few manual steps to create a word cloud in Tableau. In Power BI, there is a marketplace app for word cloud. So you simply go to the Power BI marketplace, install that app, and then drag your response field onto the tile, and your word cloud is generated. It's really awesome. And we have some time, so I would actually like to show that. So Power Apps, import a custom visual, import from Marketplace. Is it going to go? All right. Word cloud. So you simply add the word cloud app. And we are going to drag that over. Oops, okay. And then you drag the response field onto it, and the word cloud gets generated. Now you notice here, this word cloud doesn't look as refined as the word cloud back here. So there are a few customizations that you can do to make the word cloud, to clean up the word cloud, make it look nice. I'm going to show some of those. So the first thing that you want to do is go into the Format tab, General, and tell it how many words that repeat how many times. You have to define a threshold that you only want to show on the word cloud words that repeat more than a certain number of times. And that helps to cut back on a lot of noise. So the threshold that I have set up over here is the minimum number of repetitions is 5. So only words that repeat 5 or more times are going to show up on my word cloud. The next thing that you would want to set up to make things look a little bit nicer are the stop words. You want to turn on the default stop words so it eliminates all of the junk and noise from some of the stop words. And if you do not have default stop words, you'll see it has things like off. It's not really of any value to determine that the word off has occurred so many times. You can also have your custom words into the stop list. So down here, you can add some of the words that you know are not of much value for your analysis, and putting those into this field is going to eliminate those words from your word cloud. So these two things help you eliminate a lot of noise from your word cloud, makes your word cloud look cleaner, much more professional. The last word cloud that you saw over here, it has text that has been like rotated and twisted and all kinds of fun things. So you can turn off rotate text, and then it shows all of the words in one line where you don't have to like tilt your head either ways to try to read it. So that's the word cloud. And that kind of wraps up the qualitative part of the analysis. Any questions so far before we move on to the quantitative part? Anyone? Anyone? No? Okay. All right, so moving on to the quantitative part, this is where you will see a lot of graphs and charts and all kinds of fun stuff. So the first type of analysis that I'm doing here is very, very basic. You are looking at averages. Averages, they help you identify or they help you get some kind of information to be able to compare one team with another team. It helps you compare one manager with another manager. It helps you with trending. How is a particular team performing over time? All that kind of fun stuff. So the very first graph that I have tells us the average of sentiment score by period across all of the teams and across all of the managers. And you'll see here between the third quarter of 2018 to the second quarter of 2019, the average trend has gone up. So as I was telling you, we had a really difficult Project X that was going on in the last 2 quarters of 2018, and people were very unhappy about having to work overtime on that project. But once that project ended, people were happier. And you can see that reflected in the average score trending over the 4 quarters. It has gone up. Now, happiness peaked once the project was over, and then it kind of stagnated, because it's human nature to not be happy for too long with what you have. So people were like, oh, now we need something more to be happier. I'm sure our management will cook up another difficult project, and then team morale will drop down. Once the project ends, they can say that, ooh, we have done something and now our teams are happier. Since there aren't too many people from Missouri, I know this won't go back, so that's all right. Okay. Something interesting that you can do here is filter this by theme. So as an aggregate, as an IT department, we notice here that the trend has been going up. But is that the case for individual teams as well? Let's take a quick look. So I'm going to randomly pick Team 6. And it looks like for Team 6, the morale or how the team felt about their team's health has taken a drop when Project X ended. So maybe these guys were ops people, DBAs. We developers usually take the brunt of a project during the development phase, and then we develop something, throw it into production, and we are now happy. But the DBAs then have a really, really difficult time because we have put something in production that doesn't necessarily perform well. I know from some of the de-identified data that Team 6 is our DBA team, and I am on the data analytics team. So we did something that did not perform well in production, and for the first quarter of 2019, our DBA team was super unhappy. They had to work long hours, they had to tune some of our code, but eventually all of that passed. We collaborated very well, and their morale shot back up again when all of the problems were solved. So these are some of the insights that you can draw just based on one simple graph. The next thing that I wanted to take a quick look at is the average of sentiment scores by manager. So these themes, how many themes do I have? 9 themes. They are managed by 3 managers, and we can compare overall the morale of all of the teams belonging to manager 1. How does that compare to the morale of all of the teams belonging to manager 2 or manager 3? You can also do this comparison by period if things have changed. So in this graph, on an average across all 4 periods, it looks like manager 3, his team was the happiest, and manager 2, their team wasn't. Let's see if that is true for 2018 Q3. And things have changed. In 2018 Q3, manager 1's team was the happiest, and manager 2's team was still the unhappiest. And let's see if things have changed in 4 quarters. Yes, they have. Manager 2, their teams were the happiest. in the latest quarter of 2019. So another set of insights that particular manager can now try to go back and figure out, have they done something or has something happened to all of their teams where some of the teams' morals have gone up, have they gone down? The senior managers, the VPs or directors can take a look at this and have a conversation with that particular manager. Hey, looks like your teams were happier 4 quarters ago, and on an average, your teams are no longer as happy 4 quarters later. So what's going on? Let's take a look. Some of this is actually actionable information for our company because our company takes the Great Places to Work concept very seriously. They take culture and how happy our employees are pretty seriously. So they actually look at these dashboards and act on them. No pressure on me. And the last graph here looks at the average sentiment score by team. So you can compare one team with the other. How did they perform in general? How happy is one team compared to the other? And you can, again, do this filtered by a period and check if things have changed between one quarter to the next. The next set of graphs that I'm going to show are some bar charts and histogram. Before I switch over to that, any questions, any thoughts on the first set of analysis where we are simply looking at averages? All right, that looks good. So let's move on to the second one. Okay, so in the second chart, I have a histogram, but to be able to give some context to the histogram, I'm doing some counts. Some teams are smaller, some teams are larger, and that might play a role into how happy teams are versus if there is a conflict between the team members. Generally speaking, the more people there are working together, the more opportunities for conflicts. So usually larger teams will have a lower sentiment score. Smaller teams will usually have a higher sentiment score. So you have to take that context into account when you present some of this information as well. So team 4 is the smallest team, and team 6 is the largest team here. So you want to take that into context as well. You also want to take into context the workload for a manager before trying to reprimand that manager that, hey, looks like the morale of your team has dropped. Well, if that manager used to manage a team of 20 people 4 quarters ago, and now he's managing a team of 80 people, maybe that manager needs some help to be able to better manage the health of their team. So these kind of contexts are also really important when you are extrapolating or getting insights from your data. With that context, is there a question? No? Okay. So with that context, we want to look at a histogram that shows you the distribution of scores. Just a show of hands, is everyone familiar with a histogram? Okay, all right, that's great. So I don't have to talk about what is a histogram. I love that because I'm not really good at statistics. So a histogram shows you the distribution of values across your x-axis and how many data points are available across those bands. So what this is telling us is we have a form of bimodal distribution, meaning that we have polarization in terms of how people feel about the health of their teams. There is a good number of people that feel very positively about the health of their teams on an average, and that is reflected by a concentration of high bars on the right-hand side towards the positive end of the spectrum of scores. and then there is some distribution over all the way on the left-hand side as well. And the center is kind of sort of empty. So, so this means that some people feel extremely positive about the health of their teams, some people feel extremely negative about the health of their teams, and there isn't much in the middle. Not many people feel neutral about it. So one way to interpret it is that your employees are very passionate. They are hopefully engaged to voice their concerns when they don't feel happy, and on the other end of the spectrum, they are also good enough to give you positive feedback when they feel really happy. So an engaged employee is always great to have, because when there's something in the middle and people don't say anything, you don't know what's going on. You can filter this again by team, by period, by manager, and see how things have changed over a period of time, see if things have changed between one theme to the other. I just want to show this for one theme. Let's look at theme 6 once again. And you see a similar distribution. There is one little bar in the middle, and again polarization on two ends. Let's see if we have something in a normal distribution form as well. No, pretty much all themes are kind of polarized. They're either extremely happy or extremely mad. So one other way of looking at some of these polarizations is a box plot. And the next thing that we are going to look at is a box plot. Is everyone familiar with a box plot? Okay, some folks are, right? Me, not coming from a statistics background, I used to have some difficulty interpreting all of the things that are on a box plot. So something that I do to be able to interpret a box plot effectively is look at two things. You have on your y-axis the sentiment scores, and on your x-axis you have the various themes. So for every box, you want to look at the position of that box relative to the y-axis. Is that box sitting higher up on the axis, or is it sitting lower on the axis? And that tells you the average sentiment felt by the team. If it's higher, then overall that particular team is feeling good, their overall scores are high. The second thing that you want to look at is the width of the box, or the height of the box. And the height of the box tells you again the distribution of the scores. If the box is really tight, that means everyone on the team feels the same way about their theme. If the box is really tall, that means there is enough variation where you can detect that there are a good number of people feeling extremely positive about your theme, and a good number of people feeling extremely negative about your theme, and there may be some in the middle as well. So we see here for theme 7, the box is really tight, and the box is kind of located towards the higher end of the spectrum, around 70%. So you can tell that this theme is a tightly knit theme, and everyone on that theme is experiencing the health of their theme in the same way. So everyone feels relatively good about the health of their theme. You can look at one more, theme 5. The box for this theme, its height is pretty large compared to theme 7, and the average is a little bit lower. It's close to 0.6. And what this tells you is there are some people in the team who are experiencing theme health that is more positive versus others. And this is a good thing for a manager to intervene into and talk to people. You may have situations where some people on the team are working on a really difficult project for a long time, and they're really frustrated and they feel negatively about their team. And there are others on the team who may be working on an easy project, don't have too much workload, and they're pretty happy. So you may have an opportunity to cross-train, do some knowledge transfer, overall help your team members help each other so they all feel the same way about the theme. So that's like my simplistic explanation about a box plot. Any questions, comments about a box plot? All right. The next thing that we are going to look into are the details. So we looked at the fact that there are 300 rows, 300 responses to look into, and HR or management, somebody who is not a lead of that team, someone who is not a manager of that team, is not going to have the time, energy, or the motivation to look at all of these responses. There may be some value to be gained from looking at those responses, but reading through 300 responses is like drinking from a fire hose. So you don't necessarily want to do that. You want to provide your user with some mechanism to filter on those responses and look at maybe the most positive responses for a feel-good factor that, hey, I want to find out what people are really happy about and reinforce those things. Or from an HR perspective, they might want to find out what people are really upset about, look at the most negative scores. So this is where you provide a filter, a slicer basically, and allow them to pick and choose if they want to see a range of scores that are most negative responses, if they want to see responses associated with the most negative range of scores or the most positive range of scores. And there was one thing that I totally forgot to mention, which I should have talked about when dealing with the histogram, is binning. One of the things that histogram needs to be able to generate itself are the bins that you create, because our scores go from 0 to 1 in increments of 0.01. But histogram, we are doing binning, and we have ranges that go from 0 to 0.1 to 0.2. So what I did is created a group over here. So to be able to create a group, you simply click on this and say new group, and it brings up a group type. You want your group type to be a bin, and here I know that my response range is only going to go from 0 to 1, so I want only 10 bins. But you have the ability to either select the size of the bin or number of bins. So I'm going to do 10 bins over here and hit OK, and it's going to create a new column for me with the bins. And that is the new column over here, sentiment score bins, which you use on the x-axis of your histogram. And that is the same column that I used to create my slicer over here. So you now have the ability, someone from HR has the ability to say that across all teams, across all periods, show me the most positive comments. Maybe they want to feel good about themselves today, and if they want to see the most negative comments, they can just select this one and see what are the most negative comments. They can filter this by theme, or they can filter this by period, by manager. You give your users all of the options to allow them to slice and dice this data to fit their needs, to fit their analysis. Yes?
What if you see things that you might disagree with, like the third line says great team to work with and any issues are already plans to fix? So when you look at things and disagree with maybe the sentiment on
Yes. Yes, so that is a good question. So the question is the accuracy or reliability of the scores generated by the sentiment API. Yes, and there are going to be some issues of this nature as an output of the API. It's not 100% accurate. There are cases like these where you don't necessarily agree with the fact that this particular comment should have a score of 0.09. I disagree with that. But you will notice as an aggregate, this does provide you with reliable information, And what I like to say is don't look at individual lines too seriously. You will find these kind of wrong needles in the haystack every now and then. But on an average, when you aggregate these across hundreds of responses, you are generally getting a pretty reliable, a pretty accurate analysis. Yes, you have to warn your users to kind of watch out for some things like that. Yes?
Could I just quick follow-up on that? Does the service or API itself expose a mechanism that will allow you to unpack how it arrived at this? Or in further detail without
Yeah. So the question is the service for the API, is that going to allow you to unpack this and try to find out what was the reason that a negative score was associated with this? Unfortunately, no. Something that I have learned to do is create a service request with Microsoft, specifically give them this example, and they send it back to their machine learning teams, their product teams that work on these APIs, and they have been pretty good about improving that API. Yes, one more question?
This is a funny question, but I have to ask this. Do they manage sarcasms?
So the question is, do they manage sarcasm? And unfortunately, the answer is a pretty strong no. This is not designed to detect sarcasm. This is not designed to detect underhanded comments. So no, you will not get good results when you come across texts that have sarcasm.
Yes, I agree, right? So how do you handle it in your production?
Right now, the way we handle it is in terms of user training. And before we send all of this, we have a scrubber as well. We have a list of words that are no-no. And we eliminate those lists of words from some of the responses. You can't stop people from necessarily writing something that they absolutely want to write, but you can try to prevent sending some of that stuff to the algorithm. But you kind of have to take some of these responses with a grain of salt. Any more questions about this? Comments? Yes?
Maybe when you're done with your presentation, we please go back for line 1 and 3 and see what are the key phrases it extracted based on which it that question. It has great, line 3 and great, which is a positive keyword.
Yes. So good question. The question is, we want to take a look at the key phrases because you feel that the word great has a positive connotation. And that comes back to the fact that the key phrase is not necessarily the word on which a sentiment score is generated, because the key phrase is the topic of interest, and the sentiment score is not necessarily generated on the word that has been detected as the topic of interest. And to kind of show what I mean, you look at this. My team is great and fun to work with. The key phrase here is team. The key phrase is not great and fun, but you can tell that the sentiment score is generated on the words great and fun, but the topic is theme. All right, so I wanted to quickly go into R and talk about extracting human emotions. So this is something that Kevin Kline also mentioned in his talk yesterday, that there are universal human emotions. There are 7 basic human emotions. And if you look at a picture representing these 7 basic human emotions, no matter what language you speak, where you are in the world, you would be universally able to identify with those things. So if you see a picture of someone who is happy, you can, no matter what language you speak, you can identify that the person is happy. Similarly, if the person is angry, you can identify the picture of an angry person, no matter what language you speak. So there is some value to be gained from taking a look at what is the percentage of these 7 basic human emotions that occurs across the text that you are trying to analyze. So you don't have an easy way to do this for using an out-of-the-box function in Power BI. So I wrote an R script. Well, I shouldn't say I wrote an R script. In the resources section, you will find a link to where I found the R script to do this analysis on various blog posts. So I put some pieces together and did this analysis for my text. And then I was like, oh, you know what? Power BI now has a feature where you can run R and Python directly in Power BI. So I don't need to depend on an external tool. So going into Power BI, you can simply invoke an R script, and it will bring up the same graph for you. So we are going to do that. My R script prompts the user for the input file. So that is why when you click on that page, you see a prompt. So I'm going to go into C drive, demos, team held raw data for demo txt, and it's going to run my R script, and it should generate the same graph. All right, so now we have the same graph. And you don't have to go outside of Power BI to do this kind of analysis in R or Python anymore. You can basically do all of this using R or Python. This visualization allows you to run R scripts in Power BI, and the next one, Python visualization, allows you to run Python scripts in Power BI. Something interesting to note here is the fact that 40% of the responses show a human emotion of trust. And knowing some of the context behind it helps management take some decisions or feel good about the decisions that they have taken. It kind of helps them identify if they are doing something right or not. The reason I say this is I talked about the fact that we were going through Project X, which was really difficult. And in spite of going through a contentious Project X, you notice that the analysis of all of these responses that people have made about the team's health, 40% of the people, or 40% of the responses show the human emotion of trust. So in spite of difficult times, people have a high level of trust within the team, and that is a sign of a really good team. So management, leadership, HR, and the team members themselves are doing something right, and they should continue doing those right things because people have a high level of trust within their teams. That is amazing. And then towards the lower end of the spectrum, you will see there's sadness, there's anger, there's disgust. Luckily, there is not a lot of disgust, so that's good. But this kind of helps put some of the things that are going on in your organization, some of the things that are going on in your team in context of human emotions that are not easy to capture using a numeric value. Any questions about this? Yes? This is from the ShoesIt package, and I'll show you. I actually have all of this code in the demos as well. Yes, another question?
Is there a practical max length of the text that you're going to analyze?
So the question is there a practical max length of the text that you are going to analyze? In Azure, yes. So the largest text that you can send to the API at one time is 5,000 characters. If your text is larger than 5,000 characters, then you have to break it down. I believe that limit is true even for the premium tiers, but I'll have to verify that. I'll check on that and get back to you. If you're doing things in R, you don't have those kind of limitations. If you're doing things in Python, you don't necessarily have those kind of limitations. I have not written this script in Python, so don't take my word on it. Any other questions? Nope. All right. So with that, let's see where we are in terms of our slides. So we looked at the demos. Oh, we did look at a lot of demos. All right, so this is the ShoeSet package that I was talking about. And further down in the resources, we are going to take a look. You will find the link to all of this code as well. All right, so that brings us pretty much towards the close of our discussion today. So in conclusion, we talked about what is qualitative analysis versus quantitative analysis. We looked at how we can combine those techniques to gain some insights from our data using a real-life scenario. Text analytics APIs, we went through some Power BI stuff. Visualizations, dashboards, we looked at something that can be done in R, which doesn't have a built-in function in Power BI, but now you can run R scripts in Power BI, so I was super excited about it. And then
About the R script, was that using any of the information derived from Azure, or was that solely R working on the text?
So the question was, the R script, is it using any information derived from Azure, or is it working on the raw data? The answer is this was working purely on the raw data, because the output of the Azure APIs are key phrases and sentiment scores, whereas the R script requires the raw data to do its analysis on top of. So we are feeding it the raw data directly, the exact same raw data that we feed to Azure. And yes?
So the R script does not send in a call to API?
No, the R script does all of this on your machine.
So which library does that?
There's the ShoeSet package,
Okay.
and in the resources section of the slide, you'll find links to all of those scripts as well. And those scripts are also available in the demos that have been uploaded to PASS. So the last thing that we talked about, and it's not necessarily the last thing, but we talked about it throughout looking at all of the visualizations, is how do you gain insights from each and every one of those visualizations? How do you put various things together and try to get some context and not look at just one visualization in isolation, but look at the big picture. So that is pretty much the conclusion. Please submit your evaluations. This is only the second time that I have spoken at PASS, so I would really appreciate feedback to make things better. And thank you very much. Thank you.